If you see import java.util.Date in your code, you can have time-related issues. So today we diagnose this common problem and fix it with a modern, reliable java.time API. Let's examine a piece of code using the old java.util.Date. We'll set a specific time before daylight saving event. Now let's print this start time. It appears to be correct. Next, we will add what we believe is exactly 24 hours. But when we check the result, the time is off by 1 hour. This is critical failure. This happens because the old date API has several design flaws. First, it's immutable. Calling setTime changes the original object, which is unsafe. Second, it's confusing. It doesn't truly store a time zone, leading to unpredictable behavior when printed. Third, it's API requiring a separate calendar object for most operations. For machine-readable timestamps, always use instant. It represents a single moment in UTC. This object is immutable, meaning every operation creates a new safe object. Adding a day is now clean, readable, and reliable. The result is exactly 24 hours later with no expected shifts. To display this time to a user, you apply a time zone using ZonedDateTime. This gives you the correct representation for a user in a specific location. Adding a day to a ZonedDateTime correctly handles all daylight saving rules, and the API clearly shows the time and offset has changed, preventing silent errors. This rule is simple. If you see import date, consider it's a legacy issue. Refactor your code to use instant for server-side logic and ZonedDateTime for user-facing displays. This is how you build robust, time-aware, production-ready systems. Subscribe.